Hello and welcome to Biology Lesson 2.01, Atoms and Molecules. This is the first lesson in Chapter 2, or Packet 2, that is titled Molecules of Life. If you remember from Chapter 1, we talked about levels of organization, and we start with atoms, and then we go to molecules. From there we go to macromolecules. Going to get cut off a little bit, so I'm going to abbreviate that. And from there we go to organelles. Well, this chapter is really about macromolecules, which are the molecules of life. But before we can talk about macromolecules, I think we should define some basic terms that we're going to need. And the first one is an atom and an element. So the definition of an atom is the smallest part of an element. Smallest part of an element that retains the properties of an element. Well, before we talk about what that definition means, we've got a word in the definition and we may not know what that word is, and that's element. So let's put elements on here. And an element is one of (118) unique pure substances made of one type of atom. Well, you can see that in the definition of element, it uses the term atom, and in the definition of atom, it uses the term element. So we can see that they're pretty well interconnected. Let's start with elements and talk a little bit more about that, and then we'll go up to atoms. So elements, if you remember from freshman science, are found on the periodic table of the elements. Currently, in our classroom, the periodic table is not listed on the wall. It will be soon. The chemistry class is still taking their element quizzes, but after that, we'll put the periodic table up. And indeed, there are 118 different boxes on the periodic table. We can think of this like our chemical alphabet. Just like we have, 26 letters in the alphabet, so we have these 118 elements. They're like the letters that let us form words. We can turn the words into sentences, the sentences into paragraphs, and so on and so forth. We can do the same thing with elements. For most of the elements, the smallest piece of that element, well, almost all of them, some of them exist as molecules, but for most of them, the atom is the smallest part of that. We used to define this as the smallest part of an element that cannot be further divided, but that's actually not true. We have found out since we started studying atoms that we can actually smash them, and we can smash them into pieces. You guys probably know about the protons, neutrons, and electrons, but you can take those pieces and smash those even further into things called quarks. So, but if you divide it or smash it, it no longer has the properties of that element. It changes its properties. It becomes something different. So that's why we had to change the definition for atom. Well, it turns out of these 118 elements, 95% of life is made up of 4. That's it. 4 of those elements make up 9. So if you took a living organism and you broke it down, 95% of it would be carbon, hydrogen, oxygen, and nitrogen. And those are the element abbreviations: carbon C, Hydrogen is H, oxygen is O, and nitrogen is N. So together, we call this CHON. So if I ask you, what are the elements that make up most living things, or living things are mostly made up of, you would say CHON, but that means carbon, hydrogen, oxygen, and nitrogen. Of these, the one that's super special, that really kind of makes life possible, is carbon. So we're going to go down a little bit further. Oh, before I move on, I want to add that the other two are, so what's the other 5%? Well, we could say 98% is SCHNOP. If we add sulfur and phosphorus, that makes up another 3%. So sometimes we'll talk about SCHNOP, sulfur, carbon, hydrogen, nitrogen, oxygen, phosphorus. And we already saw this. Remember ATP, adenosine triphosphate? So all of those phosphates are phosphorus based. But again, 95% is here, 98% is here. But carbon is the superstar. Carbon is special. We talked back in the last chapter, and I'm going to redraw ATP here at the bottom. Whoops, I cut off. Let's fix that, shall we? Must have bumped my camera. So before we talk about why carbon is special, I'm going to redraw ATP down here at the bottom. So these are examples of molecules, and I'm going to draw the other molecule we talked about in the last chapter. I'm going to switch colors here. Let's go here. And I'll color code this. Let's go with green. Okay. And we said in the last chapter, this was a phosphate, this was a phosphate, this was a phosphate. And that most of the energy, a large portion of the energy, so the energy here, the energy was in the bonds. A bond is a connection between two atoms. So here I have an oxygen and a hydrogen and a hydrogen. You see these lines? Those also represent bonds. And bonding is something we talk about an awful lot in chemistry class. For here, we're just going to mention it. But the reason carbon is special is you can see this oxygen has two bonds, has number one, number two. This phosphorus has one bond. Carbon, so if I draw a carbon atom, this is a carbon atom, and I'll put a C in the middle. Check this out. Carbon, each one of these represents a bond. Carbon can form 4 bonds. And I can put all different kinds of things here on the sides. These could be hydrogens, they could be chlorine, they could be, in the case of biology, you're going to have a lot of oxygen, you're going to have a lot of hydrogen, you're going to have some nitrogen. But because carbon can do this, it's kind of like a 3-season athlete, somebody who can play football and basketball and baseball. They can kind of do it all, and that's carbon. If you wanted to go even further, a scholar athlete who can play all the sports and always gets good grades. We all know somebody like that, right? So that's why we see carbon in so many of our compounds. Well, when we put these bonds together, what we said is atoms combine to form molecules. And a molecule is, the definition of a molecule, smallest piece of a compound. Well, there we go again, using a word in our definitions that we need to define. So let's define a compound. It's a substance made from two or more elements. So ATP is a molecule. H2O is a molecule. I've got oxygen and I've got hydrogen. Here I've got, these are all carbons. I've got some sulfur. I've got a nitrogen. I think I have a sulfur. No, I take that back. I lied. No sulfur. There's a nitrogen, I believe, but we've got lots of carbon, lots of hydrogen, oxygen, and then we've got these phosphorus groups. Over here, I've got hydrogen and oxygen. If I threw some hydrogens up here, I'd have methane, and that's a molecule. That's the smallest piece of the compound methane. This is the smallest piece of the compound water. This is the smallest piece of adenosine triphosphate. We represent compounds with formulas. So the last thing we're going to talk about are molecular formulas. And these are molecular formulas. Molecular formulas represent the elements in a molecule. So we write water as H2O. We write a carbon with 4 hydrogens as CH4. And there are some very common molecules we're going to be using. In addition to some of these, CO2, carbon dioxide. One that we're going to use all the time is C6H12O6. This is glucose. It has 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of glucose, for a total of 24 atoms. Now, this is getting to be a pretty big molecule. This is where we begin to cross from molecule into macromolecule. This guy has 1, 2, 3 atoms. This has 5. Now we're up into 24. Now, this is the smallest macromolecule we're going to talk about. It's called a monomer. But you can see how things like carbon dioxide and water are much smaller, but still made from the 118 elements. Again, this should have been reviewed from your science class your freshman year, but this covers all the basics that we need to know about atoms and molecules. And what we're going to do for the rest of the chapters, we're going to talk about macromolecules. All right, thanks for watching and have a good day.